Good day, students. Today I want to discuss a very important topic in further mathematics, in which as a scientist or engineers, you have to take note of it very well, because it's a very important topic titled Formation of First, Second, and Third Order Differential Equations. Okay, it's being taught in secondary school and also in higher institutions. Please listen attentively. And also it talks about relationship between the dependent variable y. Okay, dependent variable y and independent variable x. Okay, and also it will deal with a constant when you are deriving. Okay, so it's a differential equation is a relationship between an independent variable x, a dependent variable y, and one or more derivatives of y with respect to x. Okay, the derivation that has the highest derivative will be named as the order. For example, if you have the square y over the x squared plus dy over dx, the one that is having squared is referred to as second order derivative. That's what you are going to name with it. And also when you have a constant in an equation, you are going to eliminate, you are going to do it such a way that the all those constants will not show, it will be removed. You are going to see the way I will do it right now. E.g. xy d square y over dx square plus y dy over dx plus e raised to power 3x equal to 0. This one now, because having this square here, is the second order derivative, second order differential equation. This one is second order differential equation. Differential equation represents dynamic relationship, that is quantities that change, and are thought frequently occurring in scientific and engineering problems. Okay, the order of a differential equation is given by the highest derivative. Let's say x dy over dx minus y squared equal to 0 is an equation of the first order. You can see dy over dx, equation of the first order. When you are deriving it, when you do the first derivation, that is the first order, and you make sure that both the constants are being eliminated to be in the form of x and y. Okay, let's see the second one. Xy the square y over dx square minus y square sine x equal to 0 is an equation of the second order because of this square. Let's see the third one. We have d cube y over dx cube minus y dy over dx equals exponential e raised to power 4x equals to 0 is an equation of the third order because of this cube. Okay, is the third order differential equation. Now let's consider this example. Consider y equals a sine x plus b cos x, where a and b are two arbitrary constants. Now let's start with y equals a sine x plus b cos x. Don't forget that when you are differentiating d of cos x, d of dx cos x gives minus sine x, and when you are differentiating sine x, will give you cos x. These are standard. Okay, now I want to differentiate this now. Dy over dx equals a sine x as cos x plus b. When you differentiate this cos, we have minus sine x. We have it to be a cos x, positive and negative as negative, minus b sine x. Now let's do the second derivative. This squared y over dx squared, because a, and differentiate cos, x, we have minus sine x plus b. So you already have it here, minus b. What is sine x? When you differentiate sine x, you have cos x minus b cos x, which is minus a sine x minus b cos x. How do you know that you need to differentiate twice? When you have two arbitrary constants, you are going to get the second derivative, arbitrary constant. When you have one arbitrary constant, let me say you have one arbitrary constant, stop at the first, give us first derivative. Okay, we're going to see what I'm saying. Now let's see, we have the second derivative here, which is equals to negative, let's factorize out, minus a, negative is common, sine x plus b cos x. You can see, because we have to remove this constant when you are solving differential equation. Remove the constant, and that's why you have y equals to a sine x plus b cos x. Now dy this squared y, d squared y over dx squared equals to minus y. Okay, take this minus y to this side to form an equation. Now d squared y over dx squared plus y, negative, when equals sign negative, y turn to positive y because it's 0. This is a second order differential equation. Second order differential equation. Okay, now let me say you want to get the first. This one has two constants. Let me say we are having it to be like this. To get the first order differential equation, let me say you must have one constant, y equals to a sine x. We have one constant like this. You have dy over dx equals, when you differentiate sine, you have cos a cos x. That's it, a cos x. When you have a single constant to give you this one. When you have a constant, it will give you one derivation. Now, since you have two constants, we have to differentiate it twice. Okay, that's why you now have d squared y over dx squared plus y equals to 0 as our second order derivative. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. And also, if you want me to lecture you from anywhere in the world, you can do Zoom by connecting through online. And also, you can also go live to also explain all this we are doing. Thank you for listening. Have a wonderful day.